Number 84. Answer the following questions about the macronutrients calcium, magnesium, and sulfur. And I've written the abbreviations or the chemical formulas for these three elements. So you got lots of questions here. The first one says wants you to classify them as metal, non-metal, or metalloid. So to do that, it helps to look at figure 2.1, which color codes the periodic table according to metals. The greens are the metals, the blues are the nonmetals, and the oranges are the metalloids. So calcium is over here. Okay, that's a metal. So here I'll just put for A, this is going to be a metal. Magnesium is right above calcium. It's also a metal. Okay, metal. And then sulfur is over there in the nonmetal region. So non-metal. Now B, what is this having us do? In which block does each element reside? Okay, the blocks are down where it starts talking about the electron configurations. Is that it? No, that's not it. Blocks are, give you another periodic table that helps for the blocks. Not that one, it's coming up. There it is, figure 2.9. So here, the first one, I'm just going to say figure 2.1, but this one we're going to use figure 2.9, which tells you the blocks. Now over here you got the S block, the D block, the P block, and the F block. And that just tells you where the last electrons go when you're writing the electron configuration. Okay, if it's over here, the last electrons are going to be S electrons because it's in the S block. Now, calcium and magnesium, you got calcium is right here, magnesium is right there. So these are both in the S block. Okay, so I'm going to put S block, S block. Okay, there it is right there. Calcium and magnesium, they're in the S block. And then remember, sulfur was over there. I'm sorry, sulfur was right here in the P block. There it is right there. Okay, right there. So P block. P block. So what do we got next here? C. Which element has the smallest atomic radius? Which one has the smallest atomic radius? Now remember, the atomic radii, this is the big corner. Okay, that's the small corner. So out of these three, which one is closest to the small corner? Well, that would be sulfur. Okay, that would be sulfur. You got sulfur, magnesium, and calcium. So sulfur would be the smallest atomic radii. So I'll just put right there, smallest radius, atomic radius. And then D. Oh, by the way, this periodic table is not in your textbook, but I uploaded it to Lima. So D says, which element has the largest atomic radius? Well, that would be calcium because it's closest to the big corner. So there's calcium right there. Calcium, magnesium, and sulfur. So calcium would be the largest atomic radius. And then there we go, largest. There, you can see it now. And then F. whoops, E, I'm sorry. There we are. Which element has the largest ionization energy? Okay, now ionization energy trend is opposite to atomic radius trend. So whatever one is the largest atomic radius has the smallest ionization energy, and whatever one is the smallest atomic radius has the largest ionization energy, because it's very hard to remove electrons that are close to the nucleus. So these small atoms have very large ionization energies. So that would be the sulfur. Would have the largest ionization energy. And I'll write that down in sulfur's column. Largest IE. And then what's F want? Okay. Which element has the smallest ionization energy? Well, that would be the the biggest atom would have the smallest ionization energy. So we'll put that down in calcium's column. And then finally, G. Lots of questions here. G. How many valence electrons does each element possess? Okay, this one's kind of easy because these guys are main group elements. Okay, when you got elements that are in the S block or the P block, you can read the valence electrons right off the group number. Okay, it only works for groups 1A, 2A. It doesn't work for the B's. It works for the A's. So it only works for the A groups. Now, magnesium and calcium are right here. They have 2 valence electrons. Okay, so I'm going to put 2 valence electrons for calcium, 2 valence electrons for magnesium, and then sulfur is right there. It's got 6A, 6 valence electrons. Okay, if you don't believe me, go ahead and write the electron configurations for these guys and count the valence electrons yourself. But I'm telling you, you can read them right off the group numbers if they're in the A groups. It doesn't work for these guys. Okay, the B groups don't work. It's just the main block elements, those A group elements.